So it's based on the material that we did on Tuesday of this week. So let me show you this one. This is the tutorial sheet for today. And there are six questions. The first one I have already done as part of the review session on Tuesday. So you can start with number 2, question number 2, which is to show that C equal to the minimum of U1 and U2 is a copula. So what you need to do is to show that the 6 conditions are satisfied. I'm sure you guys know what to do. So you need to basically show that each of the 6 conditions is satisfied. Okay. So let's start with why there are few people here only. There are only not many people coming to class today. Okay, let me change the video to the camera. Hi, welcome everybody. So I will start with question 2 of the tutorial sheet. So which is to show that the following C U1 comma U2 equal to the minimum of U1 comma U2 is a copula. Right, so this is the question. So we'll start with condition 1, which is to show that C U1 comma 0, which is the minimum of U1 and 0, and the minimum of these two is clearly 0. So condition 1 is satisfied. Condition 2, C0 comma U2. So this is the minimum of it's a minimum of 0 and U2, which is once again 0. So condition 2 is satisfied too. Condition 3, U1 comma 1. So this is the minimum of U1 comma 1. Remember, by definition, U1 is a number between 0 and 1, right? So the minimum must be U1, right? So this condition is satisfied. And condition 4, I did the other way around, it's okay. It's 1 comma U2. So this is the minimum of 1 comma U2. Now, once again, U2 is a number between 0 and 1, so the minimum must be U2. Okay. Now, condition 5 is the partial derivative with respect to U1. Right. So to do a question like this, whenever you have a minimum or a maximum, the way to do this is like this. You take the partial derivative. Right, the minimum can take 2 possible values, U1 or U2. So it can be equal to U1 if U1 is less than U2, right? it can be equal to U2 if U1 is greater than or equal to U2, right? So now you can take the partial derivative inside the brackets. So if you do that, this is what you will get. The partial derivative of U1 is 1 if, and the partial derivative of U2 with respect to U1 is 0. All right, guys? So this is clearly greater than or equal to 0. So condition 5 is satisfied. And finally, condition 6 is the same thing, but the partial derivative is with respect to U2. Okay. Now, if you differentiate with respect to U2, you will get 0 here, right? If U1 is less than U2, and 1 if okay. All right, so we have shown all 6 conditions are satisfied. All right, hence C is a copula. Okay. All right, so this is a trivial example. I mean, it's really easy to do. You guys have any questions on this before I go to the next one? Hello, guys. Talk to me. Okay, thank you. All right. So let's go to question number 3 now. Question number 3 is question number 3 is slightly less trivial, is to show that the copula given by, sorry, the function given by this, let me write it down, U1, U2, exponential minus theta, log of U1, log of U2, right? Where theta is a number between 0 and 1, including, not including 0, but including 1, is a copula, right? Right, now for the first condition, the first 4 conditions are always trivial. I mean they're easy to check. So if you put U2 equal to 0 here, you will get U1 times 0 times right, and this is clearly equal to 0 because of this, right? So condition 1 is clearly satisfied, right? Right, condition 2, right? And this is also once again 0 because of this one here. So condition 2 is also satisfied. Condition 3, condition 3 is yeah. So this is going to be u1 times 1 times e of minus theta log of u1 times log of 1. Now remember, log of 1 is 0, so the whole thing is 0, and e of 0 is 1. So this becomes equal to u1. So therefore, condition 3 is satisfied, okay? And condition 4, condition 4 is this. Once again, log of 1 is 0, so this whole thing is equal to 1. So you end up with just 1 times u2, which is u2, right? Condition 5 is a little less trivial. Let's see how we can do this. So you're going to do a partial derivative of this with respect to u1, right? So obviously you need to use the product rule. I'm sure you guys know the product rule. I did a video on the product rule as part of this course, which is on the course website. So you should know what the product rule is. Okay, so if you do the product rule, this is what you will get. Let me know if you can't see can you see my writing clearly or not? If you can't, please let me know, okay? All right, this is what you will get if you apply the product rule for differentiation, right? Now you can simplify this a little bit as follows. U2 is a common factor between these two terms, and so is so this is U, okay? Sorry, excuse my writing. Sometimes my writing is not good. So okay. So this is what you will get. You should simplify the thing. Right, now we need to show that this guy is non-negative. Now to do that, it's not difficult because remember, U2 is a number between 0 and 1, right? So it is clearly greater than or equal to 0, right? And this guy here, we know because exponential of anything is a number that is greater than or equal to 0, right? Now, this guy here, log of u2. Log of u2, because u2 is a number between 0 and 1, right? Log of u2 must be negative or less than or equal to 0, right? Okay, so, but theta, we know that theta is a number between 0 and 1. And minus of theta, so minus of a negative number is going to give you a non-negative number, right? So therefore, this whole thing here, all right, has to be non-negative, right? That's because this is less than or equal to 0, and you have a negative in front. So that makes the whole thing greater than or equal to 0, right? And therefore we have shown that this is greater than or equal to 0. So condition 5 is satisfied, right? Is that clear to you guys or not? Let me know. I mean, if it's not clear, please let me know. Okay. So that's condition 5. Now, finally, let me put this here. Finally, condition 6. Right. So here we will do the differentiation with respect to u2. Right, and it's similar to this, obviously. So here you will get u1 times then multiplied by 1 minus theta log u1. All right. So now to show that this is non-negative, the argument is the same, right? That is u1 by definition is a number greater than or equal to 0, right? And this exponential of anything is a number greater than or equal to 0. And log of u1, because u1 is a number between 0 and 1, log of u1 has to be less than or equal to 0, right? So hence, because you have a negative sign in front, this is a negative sign, this whole thing here has to be greater than or equal to 0, right? So hence we have shown that this guy is greater than or equal to 0, right? So the conclusion is that hence C is copied. All right, is that clear to all of you? You have any questions on? Let me. Can you write? Okay, thank you very much. If you have any questions, let me know. So this is question 3, guys. All right. Now the next one on the tutorial sheet is question 4. So let me go to that now. This is question 4, guys. Right. So here we want to show that the following where phi is a number between -1 and +1 is is a copula, right? First part, I mean, the first four parts are trivial. So, so you put u1 comma 0, you get u1 times 0 times all right. So this is clearly equal to 0, right? Because of this one, right? Part 2. And this is also equal to 0 because of this 0 here. And part 3, sorry, let me do this first. I'm changing the order. Anyway, it doesn't matter. All right, so this is 1 times u2 times 1 plus phi 1 minus 1 times 1 minus u2. Right, 1 minus 1 is 0, so this whole thing is 1. So this is simply equal to u2. Okay. And part 4, right, is this. Once again, this whole thing is equal to 1 because of the 1 minus 1. So you get u1. So hence condition 4 is satisfied. All right, now condition 5, which is where the work begins. So here we're going to do the partial derivative with respect to u1. Of this. So once again, you need to differentiate this, which is, so you need to use the product rule for differentiation. I'm sure all of you know that. So you should do that. This is what I'm getting. Correct me if I'm wrong. All right. This is what I'm getting. Now, obviously, you can simplify this. If you simplify it, you should simplify, I mean, you should take the sum of the two and simplify things. This is, you will get the following. Right? Okay, now we need to show that this is non-negative, right? So let's see how we can do this. First of all, u2 by definition is greater than or equal to 0, right? Now phi, we know that phi is a number between -1 and +1. So this goes from -1 to +1, right? Okay, this number here. Okay, now 1 minus 2 u1. Remember, u1 is a number between 0 and 1. So 1 minus 2 u1 will be a number this guy here will be a number from -1 to +1. Do you see that or no? Because if u1 is 0, this will be -1. Whereas if u1 is 1, I mean, if u1 is 0, it will be +1. And if u1 is 1, it will be -1. So the range of possible values of this is from -1 to +1, right? And this guy here, right? Because u2 is a number between 0 and 1, the possible values are from 0 to 1. Okay, so you have three numbers here. The phi takes values from -1 to +1. 1 minus 2 u1 takes values from -1 to +1. And 1 minus u2 takes values from 0 to 1, right? Now the product of the three, so the product of the three numbers is going to take, okay, let me put a box around this. Let me put a box around this, right? Now, the product of these three numbers, because of what is given here, will take values from -1 to +1. Do you see why? Because if you basically multiply the lower end points and the upper end points of the ranges, this is what you will get. So if you times these three numbers, the range of possible values must go from -1 to +1, right? But you have a +1 outside. So if you add a +1 to this range, if you add this one to this range, it will be from 0 to 2, which is non-negative. So hence we have shown that, sorry guys, hence we have shown that this condition is satisfied. All right, did you get what I'm saying? I mean, basically you need to determine the range for each of these terms, right? As this, and this. And therefore the range for the product will be from this to this. Now, because you are adding a +1 to this range, right? So the range for this whole thing here will be from 0 to 2, which is non-negative, right? And therefore we have shown condition 5, right? And similarly for condition 6, it's similar to this. So let me just write it down. So this will be equal to u1 right? This is the partial derivative with respect to u2, right? And once again, the argument is similar. So this guy here is greater than or equal to 0. Phi is a number between -1 and +1. 1 minus 2 u2, because u2 is a number between 0 and 1, 1 minus 2 u2 is a number between -1 and +1. And 1 minus u1, right, because u1 is a number between 0 and 1, 1 minus u1 is a number between 0 and 1. All right, so the product of these three guys, right, must be a number between -1 and +1. right? Okay, so because you're adding a +1 on top of this, it must be non-negative, right? So therefore, condition 6 is satisfied, right? So hence, C is, all right, guys? Is this clear to all of you or no? Let me know if it's not, please. Are you guys okay with this or not? Talk to me, guys. Are you okay or not? Hello, guys. Are you sure? I mean, is it all okay with you? Okay, good. All right. The next question is question 5. Question 5 is the next one. So let me do that. So here we want to show okay, we want to show that this is a copula, right? All right, the first 4 parts are trivial, so let me do them quickly. So you want to show that C U1 comma 0, which is U1 plus 0 minus 1. In brackets, you have 1 minus U1 plus 1 minus 0. Yeah. Right. So because this is 1, 1 minus 1 is 0. So basically, you get this. You get U1 minus 1 plus 1 minus U1, which is 0. So condition 1 is satisfied, right? Condition 2 is all right. Okay. Condition 2 is the following: 0 comma U2. So it's going to be 0 plus U2 minus 1. Okay. Now the 1 and the 1 cancel out. All right. So you get this power this, which is 1 plus, well, sorry, 1 minus U2, right? So this is 0. So condition 2 is satisfied. Condition 3, right. So this is going to be U1 plus 1 minus 1 plus, in brackets, you have 1 minus U1 . All right, guys. Now 1 minus 1 is 0. So 0 to the negative power is plus infinity. right? I'm sure you guys know that. So you have plus infinity minus 1 to the power minus alpha. Now, infinity plus a constant is infinity. So you have infinity to a negative power, which is 0. Right? So this is u1. Did you get this, guys? I mean, this is, you should know that 0 power to negative power is infinity. And because this is infinity to a negative power is 0. Right? And similarly for part 4, you have 3, 1 comma u2. So this is 1 plus u2 minus 1. All right, once again, 1 minus 1 is 0. 0 to the negative power is infinity. So this will be in brackets infinity plus okay. Now this whole thing is infinity, right? Because of this. So infinity to a negative power is 0. So you have u2. All right, so condition 4 is satisfied. All right, now next, let me take this away. You don't need to copy anything. I will, after the, as usual, after this session, I will scan everything and put it online. Okay. So the next one is the partial, sorry, this should be 5. The next one is the partial derivative with respect to u1. Yeah. Now, if you do the differentiation, you should differentiate what is given to you with respect to u1. This is what you will get. You will get 1 minus, I'm sure you guys know your differentiation better, perhaps better than I do. So this is what you will get. All right. Okay. Now, this you can write as follows. This times this can be written as follows. Right. This is what you, okay. Now you see that here these two terms are the same. This and this are the same terms. Now, what do you know about this term here? One minus u2 is a number between 0 and 1. So 1 minus u2 is also a number between 0 and 1. Now, when you take a negative power of it, this guy here, I mean, this term here is a number that is greater than or equal to 1, right? Okay, now you're taking away 1 from it. So a number that is greater than or equal to 1, take away 1 is a number that is greater than or equal to 0, right? So this thing, what is inside the bigger box is a number that is greater than or equal to 0. So you're adding something to this. So this is a non-negative number added to this, and then you are dividing the same thing. So basically what I'm saying is this. Let me write down. This whole thing here, right? This whole thing here has to be less than or equal to 1, right? Because you're dividing this by the same quantity plus a number that is greater than or equal to 0. So this thing here has to be less than or equal to 1. And power alpha plus 1, alpha is a positive number. So you should power something that is less than or equal to 1 to this is still less than or equal to 1. Right? So hence, 1 minus this has to be greater than or equal to 0. I hope you follow my argument. That the argument is this, one more time. You are dividing this by the same expression plus something that is greater than or equal to 0. So this guy here has to be less than or equal to 1, right? Okay, so this guy power to alpha plus 1 still less than or equal to 1. So should take 1 away, 1 minus something that is less than or equal to 1 has to be greater than or equal to 0. All right, I hope you understood. I hope you understand what I'm saying. Okay, and similarly, for the last part, part 6, right? You can show by the same principles that the partial derivative with respect to u2 right, can be written as follows. Can be written as all right. So the argument is the same, that because u1 is a number between 0 and 1, 1 minus u1 is a number between 0 and 1. So this little guy here has to be greater than or equal to 1, right? Okay, and take away 1, you should take that away from 1. What you get is a number that is greater than or equal to 0. All right, now you are dividing this by the same expression plus something that is greater than or equal to 0. So that means that this thing here, right, okay, has to be less than or equal to 1, right? All right, so a number that is less than or equal to 1, power alpha plus 1, is still less than or equal to 1. And you take that away from 1, you end up with something that is non-negative. So condition 6 is satisfied, and hence C is copular. Okay, is this clear to you guys, or is it too much? Come on, guys. Is it? I mean, my explanation, is it clear enough or not? Hello, hello, guys, talk to me. Is it? Is it clear enough? Okay, thank you. Thank you, guys. I hope you. Okay, so so that's question number 5. Finally, question 6. I don't know if I have time to finish question 6, but at least I can make a start on question 6. So it's to show that so we want to show that this is a copular, right? Okay. Right. So the first four parts are trivial. So right, because u1 is greater than or equal to 0, this has to be equal to u1 power 1 minus alpha times 0, which is 0. So it's satisfied. Part 2, so here u2 is greater than or equal to 0, so you use the second part, right, which is 0 times u2 for 1 minus beta, which is 0, so it's satisfied. Part 3, C u1 comma 1. Here u1 is less than or equal to 1, so you will use this part here, right? So it will be u1 times 1 to the power 1 minus beta, which is u1, so it is satisfied. Part 4, C1 comma u2. So here you will use this one, right? So it will be 1 to the power 1 minus alpha times u2, which is u2, so satisfied. Okay. And part 5, you take the partial derivative with respect to u1. So you can take the partial derivative inside each of these things, so you will get the following, which is the partial derivative of the first term is this. Sorry guys, sorry for overrunning. I apologize for that. I will finish in a minute. And this is clearly greater than or equal to 0, because I forgot to say that alpha is a number between 0 and 1. So this has to be non-negative. And finally, part 6. the partial derivative with respect to u2 once again, beta is a number between 0 and 1, like alpha is. So this too has to be non-negative. So hence C is a copula. So this condition is satisfied. So the conclusion is that hence okay. All right, guys, so that completes the tutorial sheet for today. If you have any questions on the stuff we did, please contact me 24/7 by any means, by phone, email, Skype, or Zoom, right? And any other questions, also feel free to contact me 24/7. And all right, I'll see you guys next week. Otherwise, all right, so have a good week, and then I'll see you next week. And right.